Alright, so now let's come back to our star circuit again. Now remember we say if they are balanced load, ZA, that means the three impedances are the same. If they are, so this is called balanced load. Balance. The neutral current is equal to 0 ampere. 0 ampere. Right? In other words, if there's no current flow, that means the voltage here, Vn n dash is equal to 0 volt, right? There's no current, so no potential difference across the 2 points. But what if? What if? So now we want to talk about what if that the circuit is not balanced anymore. ZA and ZB and ZC is not the same, so it's not balanced. Not balanced. And when it's not balanced, your IN have some value. IN have some value. IN have some value. Right? So the difference, the sum of the three current will be equal to IN, and IN no longer equal to 0 ampere, has a value. And what if we remove this wire? Then we have a problem now, right? So our circuit, for this imbalanced circuit, our mathematics has to change a little bit, because the voltage between these 2 points is no longer 0 volt. It's no longer 0. It has a value. It has a value. Okay? And we need to do this series of mathematics to find this value. Now, by using Millman's theorem, right? This voltage here, Vnn, when it's not balanced, is equal to EAN multiply admittance plus EBN multiply admittance multiply ECN multiply admittance. Okay? Then divided by the sum of the admittance. Now this is a mathematics that can be proven, but we don't go through the proof here. But let's talk about what is it all about. Now, if it's EAN, the EAN, if you remember, we said the example that we keep on using is 400 volts. So here is 400 volt. Then here will be 400 divided by square root 3, right? So EAN based on this phasor diagram here is my 400 volt divided by square root 3, 0 degree. Okay? And what is YA? Now let's say ZA is equal to 3 plus J4 ohm. Right? ZA is equal to 3. If ZA is equal to 3 plus J4 ohm, which is equal to 553.13 degree, I know my mathematics, then the admittance is a reciprocal. It's a reciprocal. So it's 1 over 553.13 degree. So that's equal to 0.2 minus 53.13 degree. So that's the admittance. So you substitute this value here, multiply 0.2 minus 53.13 degree. So that is what I've done. I've substituted this value, right? And you carry on. Carry on. So here will be 0.2 minus 53.13 degree, right? Plus. So what's EBN? EBN, if I base on my phasor diagram here, is minus 120 degree. So it's 400 square root 3 minus 120 degree. Alright? Multiply the admittance of YB. Now let's say my YB is equal to 6 plus J8, which is equal to 1053.13 degree. Right? So the admittance, if I reciprocal it, that's my ZB is equal to 1053.13 degree. If I admittance it, so that become 1 over ZB. So that becomes 0.1 minus 53.13 degree. Right? So you substitute that into here. Okay, and then you plus 0.1. Right? And then you add the third one. Alright, the third one. So I've already done this. So now we go to the third one. ECN, CN is 120 degree. Right? So 400 square root 3, 120 degree. Okay, multiply. What is my YC? Let me say that my ZC is 3 plus J4 again. So that will be equal to 553.13 degree. Right? It's the same as my ZA. Alright, so my ZC is equal to 3 plus J4, so it's equal to 553.13. So my admittance will be equal to 1 over ZC, so it's equal to 1 over 5, 53.13 degree. So that gives you 0.2 minus 53.13 degree, right? So I substitute into here 0.2 minus 53.13 degree, and I add here 0.2 minus 53. Alright, so it's a series of complex number mathematics for you to get the answer. Get it? Very tedious, but can be done. Can be done. Alright, so after we have got this one, then what do we do? Alright, so assuming that we have already gone through this tedious mathematics, we have already got this value. Okay? Then you use KVL. KVL say VAN is equal to, if I were to say, so here, if you recall, here is EAN, right? A to N, right? And here is VAN. Can you differentiate the capital E and the small v? Yeah. And then here is VNN. Correct? VNN, sorry. So by using KVL, you will say EAN minus VAN equal to VNN prime. Agree? This one minus this one equal to this one. Right? So with that, we can find out our VAN. VAN is therefore equal to EAN minus VNN prime. So just now in our mathematics, we already calculated this value. We already calculated this value. Alright? And EAN we know is 400, 0 degree. Right? EAN is here. Sorry, 400 divided by square root 3. Square root 3, 0 degree. So you minus this value that you have calculated just now. So you have found out the VAN. The VAN. So to find IAN, which is the same as IA, now you use this VAN, sorry, I forgot the prime, prime. Right? So that will be equal to VAN prime divided by my ZA. Got it? Let me repeat. What I'm teaching you now is called a theorem called Millman's theorem. Millman's theorem says if the neutral wire is being removed and the circuit is not balanced means the three impedance are not the same, then this voltage here, VAN prime, you need to calculate it. Right? How to calculate it? First of all, use Millman's theorem to find this. And that was the long mathematics expression that we did just now that involved admittance. Find this value. Then use Kirchhoff's voltage law to say EAN minus this equal to this. KVL. Right? EAN minus this equal to this. So with that, we can find out what is this one. Right? And then we use Ohm's law to find our IA. And we repeat this process. To find IB and IC. So it's a little bit complicated, but it can be done. Alright, so that's called Millman's theorem.